So guys, today we are learning how to perform tensile test of a ductile material on UTM in virtual lab. So before do the test, we have to go the solid mechanics blog. Just you have to type the solid mechanics 2019 in a Google. You will get the first blog, that is solid mechanics 2019 course. So in that you have to go for the tab practical. In that you have to press the virtual lab. In the virtual lab, the first NITK Surathkal, just you have to click in this. You will get the new window. In that you have to just type the list of experiment. So here you will get all the experiments that we are going to perform, or you will have to perform in a virtual lab. So here we have to perform a tensile test on a mild steel, that is on a ductile material. Just click on this. So the new user interface will becomes. In that, the aim to study the mechanical property of a mild steel specimen under the tension load. So if you want the theory, just go for the theory. Total detailed theory will be here. If you want the procedure, the step-by-step procedure will be provided here. The first step, click on the tensile test on a mild steel file and window will be open as shown. So this window will be comes when you click on this. So here will be the next. We'll go for the next. In the next, you have to set the dial gauge. Likewise, all the step-by-step procedure they have provided with the screenshots. So you have to follow this one. First, you have to read all the things. Just I'm directly going for the simulation. I'm going for the simulation. So here the simulation. First, this window will becomes. In that, object to study the mechanical property of the mild steel specimen under the tension load. So the apparatus will be used, a universal testing machine that we call as a UTM, dial indicator, extensiometer, scale and vernier caliper. Just click on this arrow. That will go to the next. In this, we are measuring the diameter of the specimen. Just click on the vernier caliper. Firstly, it will be take the measurement of the x direction diameter, and now again it will be vertically measuring. First it will be measuring the horizontal, second will be measuring the vertical, and we'll taking the average diameter, that is 12.6 mm. Going for the next, when clicking on the next arrow, here just click on the scale. It will be measures the specimen total length that you have displayed in the screen, 186 mm. Just click on the next arrow. Here we are marking, or we are punching the distance. That distance we are measuring as a 2.5 into d diameter. Just click on the hammer. It will punch the first punch. Just again click on the hammer. Second punch. Again repeat the procedure. Just click on the hammer. So total this much of punch we are measured here in the length. Next. Now click on this. Here the two jaw will be there, the upper jaw, and this is the middle one jaw, and here at the below side another jaw will be there, that is a lower jaw. In the UTM, the upper one and the lower one will be the fixed, and the intermediate or the middle jaw will be moving upside and downside, and we have to fix the specimen in between of the upper jaw and the middle jaw. So we have to first positioning here the middle jaw, and then you have to place the specimen. Now we have to press here. This jaw will be set to the specimen. Now it will be in the position. Go for the next arrow. Now we have to fix here the dial gauge. This we use as an extensiometer. In the extensiometer, we have to set this dial gauge as to the 0 in the initial position, and here also in the initial position. Now check here, the list count of the extensiometer is equal to 0.01 mm. So we have to go for the next now. Now we have to start the machine on clicking on the green button. See here, dial gauge will be indicating the load, and here it will be starting the load versus the deformation, and this window will be pop-upping showing that how it will be decreasing the area and increasing the length, how the extension or how the deformation will be takes place. Here the total data will be showing load versus the deflection in the extensiometer, as well as when we'll removing. In the certain period of the time only we have to put the extensiometer. After that we will remove the extensiometer from the machine or from the specimen, and afterwards again we are adding the load and the up to the fracture. So this data, if you want this data, you can download. Just clicking here the download data, this extensiometer will become in the Excel. And here the material is get in the fracture. The ductile material, it will be cut in a cup and cone shape, that will be showing or visible clearly. Now you have to stop the machine by pressing the right button. Go for the next. In the next, it will be a testing curve for the ductile material, how the load will be increases accordingly, the deformation will be takes place. Just go for the next. This is the extensiometer versus the load graph. So here, if you want a data, click here. The data will be shows how the data will be occurred and how they have to, taken. And here the slope, if you want to calculate the slope, so it will be showing that the delta x and delta y, the slope will be 2.21. The finally we have to check the final diameter, how much area will be decreasing, how much diameter will be decreasing from the initial diameter. Just clicking on this vernier. Here the diameter will be pop-upping, that final diameter is equal to 8.83 mm. That you have to take for the calculation. Similarly, we have to identify the length, how much length it will be increasing. Just click on the vernier. The final length between the punch marked is 87 mm. Just click on the next. Here you have to calculate using the data, whatever data has displayed here, and just you have to move the cursor in this box. You will get the formula, that load at yield point divided by area. When you calculate that, you will get the yield stress, the tensile strength. Just move the cursor, ultimate load divided by area. Again, here the slope for the modulus of elasticity. You have to calculate the modulus of elasticity by using slope, that what we have seen in the curve, into 1 by LC into gauge length divided by area. Similarly, how to calculate the percent of elongation, percentage of reduction in area. So after that, you have to go for the check and you will get the total details. Here you will get the graph also, and you will get the observations. Okay, this is how we have to perform the tensile test of the mild steel on virtual lab. Thank you.